Welcome viewers in my presentation on tool wire and tool life. Tool wire have significant effects on machining economy, product quality and of course, productivity. Aim of any modern manufacturing industry is to produce economical and reliable product along with the quality of the product. With the invention of newer alloys with extreme hardness and the advancement of CNC machine and its cutting tool life becomes an important factor for machining economy and product quality. Industrial data suggest that tooling cost accounts for approximately 25% of the total cost of machining. Hence, knowledge of residual life of cutting tool and corresponding optimal tool replacement time become more important than ever to reduce tooling cost as well as to increase the overall productivity of any modern manufacturing systems. First, let us discuss what are the various nomenclature of a cutting tool. Here I have given you a cutting tool where shank, base, this is the side flank angle, heel, side cutting edge, this is the nose of the cutting angle, edge cutting edge and this is the face of cutting tool. Now, what are the different types of wire happens in cutting tool? Among all types of wire, flank wire is the most important criteria for measuring the cutting tool life. Here I am showing you a cutting tool wire, just a photographic view of cutting tool wire. This VB max means it is a basically flank wire, measurement of flank wire. Now, flank wire most commonly results from abrasive wire of the cutting edge against the machine surface. Flank wire can be monitored in production by examining the tool or by tracking the change in size of the tool or of machine parts. Flank wire can be measured by using the average and maximum wire land size, that means either VB average or VB max. This is basically a photographic view of flank wire. Here you will see this is the flank wire edge. Okay. Now, this crater may occur in the rake surface of the tool, cutting tool. This is another type of wire. This is an adhesive wire. These are the different types of wire. Photographic view of adhesive wire. Thermal cracks may happen in the cutting tool surface because of the fact high heat is generated during machining, particularly high speed machining like CNC machining for harder materials. Then breakage of tool edge, that means fracture wire can happen. This is the fracture wire, cutting tool edge fracture wire, this may happen. And mechanism all here, this slide shows that this is a mechanism of tool wire, this is cutting tool, this is just abrasive wire, this is going, then it is adhesive wire, some portion of the workpiece material goes to the tool edge itself, creating a built up edge. Therefore, particularly these wire happens for cohesive bondness between these material. If these are chemically adhesiveness is there, then this type of wear can happen. It is called another type of, this is called diffusive wear. This is a, this and another called crater wear. This can happen in this tool surface. Here I am showing you a, for particular machining operations, how this flank wear is generated, how, what are the rates of flank wears. So, flank wear, this surface is shown a flank wear, and this is with respect to time, this is the time. If you observe this flank wear, initial stage it is 0 to 20, that means of course, it is an example 0 to 20 minutes, flank rate of flank wear is more or less linear in nature. Now, once this stages is crossed, the flank wear increase of flank wear, rate of increase of flank wear is less, 20 to 20. This is the, so this is the maximum period, this is the most important period where cutting tool exhibits most successful life, and then it is increasing further, it is increasing exponentially. So, I can tell that this is rapid initial wear stage, then more or less steady state, and then again it is final rapid wear stage, which is basically exponential in nature. Now, in general, if this VB max is 0.3, then it is assumed that its life is exhausted, then you need to change the tool. This value depends upon the what quality of products you want. It may be if you want, if you want a very high quality product, then VB max may be 0.3 also, 0.15 also. Then once this is crossed, you need to change the tool. Again, this is an microscopic view of cutting tool. So, this is a carbide insert, example of carbide is HSN10, whose cutting speed is 150 millimeter per minute, and this is the flank or image of this. You see this initial stage of this, because of the fact this is H10N carbide insert. This is an examples of a experimental results I am showing you. Okay. Why this is important? As we know that this is basically cutting tool life is B T to the power n is equal to constant. So, life largely depends upon the velocity of the cutting tool, this cutting. This result is for cutting velocity of 150 millimeter per minute, and this is for a particular cutting for a particular E31 alloy steels. Again, I am showing you this scanning electron microscopic view of a cutting tool wire. For cutting tool HSS10, you see these are the edges here this is addition occurs, then this is the wire rate, this is the particularly this cutting tool is for 150 meter per minute, and it is for uncoated cutting tool here 270 meter per minute. Here this is a energy dispersive spectroscopy view of addition point, this point. Now, how do I model the how do I model this cutting tool wire? I can model by fitting these things entirely into taking a polynomial, and from the experimental value I can take, and this polynomial coefficient I can find out, or I can model this cutting tool wire. As I told you, it is initially it is linear, then it is more or less steady, and then it is exponential. So, I can break these three parts. I can model this piecewise, that means it is linear, it is again linear, again this is a this is again this is exponential in nature. Now, so I can model these things, or I can model the cutting tool wire based upon the rest of the life of the, how much for a particular operations, how much life is remaining with the cutting tool. Modeling the, for modeling the residual life, we take generally a Weibull distribution. Weibull distribution, this is the Weibull distribution formula. Now, why I have take Weibull distribution, why not other distributions? Because of the fact, as you see these two parameters beta and mu, these two parameters, if I change these two parameters beta and mu, I can get several types of distribution. Let me discuss why I have take Weibull distribution for modeling residual life. Residual life of cutting tool. Weibull distribution. This is Weibull distribution is equal to, say, S0 t is equal to beta a t minus bu beta minus 1. If you observe this formula, b is equal is a shape parameter, and mu is scale parameter. Idea is that by varying beta and mu, you can get several curve. This particular property of a function is called flexibility. Flexibility. So, by varying beta and mu, I can get different types of curves. Now, let me discuss modeling can be different types, maybe analytical, maybe empirical, modeling, maybe hybrid modeling. This type of modeling is preferred by scientists, and this type of modeling is preferred by engineers. Then obviously comes why this type of modeling is preferred by engineers and why this type of modeling is preferred by scientists. Say, whenever you are modeling something, I mean analytical modeling, you are taking consideration some theories, some principles, some hypothesis, and above all some assumptions. But in reality, there are some controllable factors in any experimental work. There are some controllable factors, some uncontrollable factors. Say for example, when you are machining something, machine vibration you can reduce it, but obviously it will be there. So, you can the effect of machine vibration for you are not considering for analytical modeling. Another example is for any real life function is differential in nature. That means, with respect to something the output is varying. Say for example, this tool wire, every time it is happening in the tool. So, what should be the basis of modeling? Therefore, engineers prefers this type of modeling because of the fact here both controllable factors and uncontrollable factors are taken into account. You are taking the output and going back to the model. Basically, you are fitting a curve maybe linear or non-linear from the output data. I do not know what is the distribution output data. That is why this type of flexible curve is taken, this Weibull distribution. So, actually this to compute the residual life, this particular value and this particular value is computed from the distribution. So, that what is the nature of the tool wire in the cutting tool, from the distribution we want to find out. Okay. Now, for this this type of function is used. This is basically this term is called baseline hazard. This term is called baseline hazard, and this particular model is called proportional hazard model, where you can calculate the rest of the life of the cutting tool. This is important for inventory purpose of cutting tool, where you want to, when you want to purchase the cutting tool for the inventory itself. So, in this lecture I have covered what are the importance of tool wear and what are the importance of computation of residual or rest of the life of cutting tool. What are the different types of tool work that can happen for machining, what is the mechanism of tool wear in the machining can happen. I hope you have enjoyed my course. We will meet in the next class once again. Till then, goodbye.